Hi, welcome to the Exam Collection, a series of posts that come out every single Monday that contain about 6 questions that you might find towards the end of a foundation paper. So this is excellent preparation for trying to get that grade 4 or that grade 5. I would just like to say that the methods you're going to see are the methods that I use in class with my students and also within the courses that I have available. If you do it a different way and get the answer right, then as long as you are showing all of those steps to justify your answer, it's absolutely fine. It's really, really common for there to be more than one way to get to an answer in maths. So without further ado, let us crack on. So I want you to pause. This series of questions came from a calculator paper, by the way. So if you want to be grabbing your calculator, you can. Yeah, pause, press play when you're ready to see the solution. Okay, so expand and simplify means we need to get rid of those brackets and we multiply those brackets out. So we use Crabbe's law in class. X times x is x squared. X times minus 3 is minus 3x plus 9x. And then watch out for that negative. I've got 9 times minus 3, which is minus 27. And then you've got to collect that middle section up. So minus 3 plus 9 takes me to positive 6 on the number line, minus 27. So you'll get 1 mark for expanding and you'll get 1 mark for collecting that up. We've then got to make A the subject of the formula. Now that means that I need A on its own. So we use the same hopping method that we use for solving equations and inequalities, for what we use when we're doing trig and things like that. It's all about getting A on its own. So I'm going to hop the U and land it on the other side. It's a positive number. U is a number I don't know. It's positive. So when it lands, it's going to land as negative. V is already there. So V and then it's minus U equals AT. To get that T on its own, I'm going to pick up, the A on its own, I'm going to pick up the T, drop it on the other side. It's a times on this side, so it will land as a divide. So A is equal to V minus U all over T. Okay, next question. Hit pause and press play when you are ready. Okay, so we've got quite a wordy question and we've got a diagram as well, and we should always be absorbing as much information from that question as we can. So we've got an industry that makes drinks containers. They need to design a new container for 500 milliliter of drink. The container has to be in the shape of a cuboid. The base will be a square and the square has 5 on each length. And we can see all of that information in the diagram. And we've got to work out the minimum height of the container. So we know that we want the container to hold 500 milliliters. Now, milliliters and centimeters are actually different units. So we do need to check in with this. The conversion that we are expected to know is that 1,000 centimeters cubed is equal to a liter. We want half a litre, we want 500 milliliters. So that's a half. So we do the same to this side and we can see actually that this is not something that we need to worry about. The units are exactly the same. So I can just crack on with that without having to do any other kind of adjustment, but really important that we notice those different units. Okay, so the volume, the space inside is found by doing the area of the front face times by the third length. And you may have learned this bit here as a cross section. It's kind of the same thing. So my front face is going to be that square base. So 5 times 5, which is 25. And I'm going to be timesing that by the third length, by the length that takes it from being a 2D shape, a square, into a prism, into that cuboid. And that length is this length here, which is the height, is actually what we're trying to find. So I don't actually have that. So times by the height will give me the volume, which they've told me needs to be 500. Now, if I want to know what the height is, I need to get that h on its own. So I'm going to pick up my times by 25. It will land as divide by 25. So the last step in the calculator, 500 divided by 25, and my height needs to be 20 centimeters. Okay. Okay, next question. Hit pause and press play when you're ready. Okay, so the method that we learn in class is the two-tick test. That's how we start this off. So it's a percentage question, tick. It's on about an investment over a period of time at a compound interest of 5%. So I've got a period of time, and when we invest money into a bank account and earn interest, it's an increase on the original value. So this is an increase question as well. So it gets a tick for increase, it gets a tick for 5%. A two-tick question tells me to use original times multiplier equals result. And this particular question is over a period of time. The investment begins in 2004 and it ends in 2006, both in July. It's a 2-year period. And when you have a period of time, which we do here, time is 2, that becomes a power on the multiplier. So our original is 2000, times that to the multiplier. Now, this is the skill you have to bring to the exam. This is on a calculator paper. The calculator is going to do the maths. Your skill is 1, identifying its original times multiplier by doing the two-tick test, and then knowing confidently how to write a multiplier. So my multiplier is 100%. It always starts with 100%. If it's an increase question, I'm adding 5%. That gives me 105%. I don't work in percentages. Percent means out of 100. So I'm going to divide through by 2, and that is going to give me 1.05. Divide through by 100, move in 2 places. Okay, just to make that clear. Period of time is 2. So that goes over my multiplier. You pop that into your calculator and you get 2205. You then check back in with the question, work out the value of Jack's investment. That is what we've done. Sometimes they can just work out the interest he earns. And if we don't go back and check, we might miss that. And then we're losing that mark for not answering the question. So the answer is 2205. Okay. Next question. And again, very, very wordy. So I want you to read through it carefully. Think, what am I looking at? What do I know? How can I use it? Give it a good go and hit play when you're ready to see the answer. Okay, so the diagram shows a solid prism. I can see that. Prisms are 3D shapes. It's made from metal. The cross-section of the prism is a trapezium. And then they're starting to talk about what I can see in the diagram as well. So the parallel sides are 8 and 12. I can see that here. The height is 6. I can see that also. And the length is 20. So all of that worded information is just relaying what we can see in the diagram. They're now mentioning that the density of the metal is 5 grams per centimeters cubed. So that is a key word. That should trigger something almost immediately. So I'm not really thinking about the problem now. I'm thinking about that key word. Density has a formula triangle that I need to recall if it's in my question. So density, mass, and volume are all linked. We can see the word mass is in here as well. So if I hadn't quite got the trigger on density, I would have got it on mass. Now I need to know how to put these into the triangle. I've got density, mass, and volume. Okay, I always teach this as mum, if she's there, is on top. She's in charge. So mum goes on top, and then you've got your D and your V. And obviously it's not really mum, it's mass. Okay, I know I've got the formula triangle. I know that I'm being asked to calculate the mass. Using the formula triangle, I can see that mass is equal to density times the volume. My density is 5 in the question. My volume actually is my problem. I don't have it. So if I'm going to answer this question, I actually need to find the volume. And that's why they've given us so much information about this shape and where all the mass is within it. So how do we find the volume? So volume is the area of the front face times by the third length. So the area of my front face is my trapezium. And then my third length is the length that creates the 3D shape. So let's make a start. So the area of a trapezium is A plus B times by the height divided by 2. So there's a lot going on with the area. Volume's really easy if you've got all your area secure. So A and B are your parallel sides. So I've got A, 8 plus 12 times 3 by the height, which is 6 divided by 2. You can put that into your calculator and you will get 60. So the area of my front face is 60. I times that through by the third length, which is 20, and that is going to give me 1200. I now have the volume. So I can go back to my density times volume, and I can say it's 5 times 1200. That is going to equal 6,000. Now you do need to be really, really careful. Always check back in with what you're doing. It says calculate the mass. It says give your answer in kilograms. If we look over here in our density unit, we've got grams. So that means right now my answer is in grams, not kilograms. So I still haven't quite finished this question. How many kilograms are there? How many grams are there in a kilogram? There are 1,000. So I now need to divide through by 1,000 and I get 6 kilograms as my final answer. So lots and lots to look out for, which you would expect in grade 4 and grade 5 questions. So really check back in with that question all the time. Okay, our next question. Let's get this so we can see all the information. So the diagram shows a triangle. Take in all that information. Again, go through that process of what am I looking at? What do I know? How can I use it? Try and have a go at this question and then hit play when you are ready to see the solution. Okay, so looking at this, this is a question about the angles. Now, I don't know what the angles are. They're given to me in algebra, but what I do know is that the angles in a triangle will always add up to 180 degrees. So I would get that piece of information down straight away. I need to show that the triangle is isosceles. So another key word here, and I need to be thinking, okay, what does that mean? Isosceles means that two angles are going to be the same. Two angles are equal. So I really need to find the value of these angles as actual numbers and not algebra so I can make some comparisons. So my first job is really to find out what x is equal to. So I know that the three angles, all of these angles added together must equal 180. So that's where I start the problem. So I'm going to do 4x plus 8. 5x plus 2, 6x minus 10. I'm going to add up all my x's. I've got 15 x's, and then I'm going to add up all my numbers. 8 plus 2 is 10, but then it says take 10. So my numbers actually disappear. They eliminate from the problem. So I've now got 15x as a total for the angles, and the total must equal 180 degrees because angles in a triangle add up to that. If I want to know what x equals, I get it on its own. So my times by 15 lands as divide by 15, and I work out that x is equal to 12. Remember, you've got your calculator to be putting all these values in. What that now means is that I can start working out all of these angle sizes. So 4x plus 8, well, that means 4 times whatever x is 12 plus 8, that is equal to 56 degrees. This is 5 times whatever x is, which is 12 plus 2, and this gives me a total of 62 degrees. Over here, I've got 6 times 12, take 10. That gives me an answer of 62 degrees. So I can see that this angle and this angle are equal. I have shown that they are angles within an isosceles triangle. Okay. So our next question actually came from a non-calculator paper. So this one is slightly different. It's a bit of a tricky question to be doing on a computer screen. So let me kind of zoom in. Okay. It's not easy. So I made the decision to include it because I really want you to be aware of all the types of questions. So rather than do this, because you're not going to be able to, it's a hands-on question, I want you to just describe how you would do this. What would you do to answer these questions? So you've got a diagram showing part of a map. It shows the positions of a castle and a church. You've been given a scale, you've been asked about A, and there's also a B as well, which I'm going to have to make this quite small so that you can see everything. Okay, and I can just get away with that, I think. So describe what it is you would do if the paper was in front of you, and then hit play when you're ready. Okay, so the first question says, work out the real distance between the castle and the church. And it says, give your answer in meters. So what you would do here is you would measure using your ruler the distance between those two. Okay, and I know from the real exam, a question that would measure at about 8.2 centimeters. So the scale that we've been given is 1 to 10,000. I've just measured 8.2. So obviously we're going to be timesing, that side was times by 8.2. So we're going to do the same on this side, and it's going to give me a real distance of 82,000. Now remember, my ruler, my measurement was in centimeters, and they very clearly asked me to give my answer in meters. So I am going to need to check in, always look back and see what it is they want. I'm going to divide this through by 100 because there are 100 centimeters in a meter, and I get a final answer of 820 meters. I'm then being asked to find the bearing of the castle from the church. And that from, okay, is really key to knowing which part of the diagram you should be measuring with your protractor. Okay, I want to know the bearing of the castle from the church. That means I'm stood at the church and I want to know what bearing I'm going to walk on if I'm heading towards the castle. Bearings are always measured clockwise from the north. So this is my north, this is my movement clockwise. I hit my line of travel. That is the angle I would be measuring with my protractor, okay? And the answer, if you could do it properly, was 130 degrees. So that's how we deal with kind of map scales and bearings. These are not uncommon questions, so we do want to know what we're doing with those. Okay, hopefully you found that useful. I will be doing another one and releasing that next Monday.